Welcome! Today I'll show you how to deploy an ASP.NET Core 3.0 Web API on Kubernetes. You will learn how to enable a local Kubernetes cluster in your box, how to generate Kubernetes files to describe your ASP.NET Core Web API deployment using Visual Studio Code, and how to deploy your containerized Web API to Kubernetes. To follow this video step by step, you will need a few things. First, the Hello ASP.NET Core Docker image created in my previous video, containerizing an ASP.NET Core 3.0 Web API. If you had not seen it already, please go through the steps on that one and then come back. Second, Docker, which we will use to manage Docker images in the dev box, and which also includes a standalone Kubernetes cluster where we will be deploying the image. Third, Visual Studio Code, which we will use to generate and edit the required Kubernetes files. You could of course use any other code editor that works best for you, but you might miss the code generation piece. And finally, Postman, which is handy to query our web API once deployed on Kubernetes. Again, you're welcome to use a browser instead for this if you prefer, or any other tool that better suits your needs. The first thing that you want to do is make sure that Docker Desktop is running. And that you can do very easily by opening up the tray icons here and just looking at the Docker Desktop icon. It should say Docker Desktop is running. If that's the case, then Docker is up and running. Now we're going to open the project that we created in the previous video, where we have all the files for this web API that we're working with. And I just opened already a terminal here. And in this terminal, we're just going to query for Docker images to make sure that we already have the image that we'll be working with. So we'll do Docker images. And here it is. Hello ASP.NET Core v1 is there. Now, next step is to enable the Kubernetes cluster in our Docker Desktop installation. To do that, we're going to open the tray icon, right-click on the Docker icon, click Settings, go to the Kubernetes tab here, and then click on Enable Kubernetes. Apply. Click Install, and this may take a while, but this is going to pretty much download a bunch of Docker images for Kubernetes into your box and enable a very simple one-node cluster in the box that you can use to start exercising all the Kubernetes functionality. When installation is complete, we can go ahead and close this, and you should be able to see that both Docker and Kubernetes are running in the box. Then we'll just close this dialog here. And what you want to do now is make sure that your Kubernetes context matches the Docker Desktop cluster that you have in your box. So to do that, there's a couple of ways. One way is to, again, open the tray icon, right-click in the Kubernetes section here. You should see Docker Desktop already selected there. And the other way is by using the CubeCTL tool. So this tool comes installed with a Docker Desktop. So you should be able to do CubeCTL config get context. And that should bring up the Docker Desktop context that we already saw in the tray icon. For some reason, it will display more than one Docker Desktop, like this Docker for Desktop other one here, but it doesn't really matter. The one that we care about is already pre-selected. And just for a little bit of context, this Kubernetes context is just a logical grouping of your cluster and a bunch of other related settings. And so they will change depending on which cluster you're working with. So you always want to make sure that you're set in the right cluster. Now, if for any reason the CubeCTL tool is not found in your box, you may want to just go ahead and in this case close Visual Studio Code and reopen it because it should be available in your pad, in your machine pad. And if you're using just a command line, you may want to just close it, open it again, and CubeCTL should be there. Now, in Visual Studio Code, it's time to start creating YAML files to describe the Kubernetes artifacts that we're going to be using. To do that, one thing that I can recommend is to install the Kubernetes Visual Studio Code extension, which can generate this stuff for us. So if you have not done it already, go to the Extensions Hub, look for Kubernetes, and the first result here should be the extension that you want to install. So just go ahead and install it. It will take a few seconds. And this will enable the generation of Kubernetes YAML files. We close this. Now, one thing related to this, and let me just clear up this, is that the Kubernetes extension by default will also install this other YAML extension. But as of the time when I'm recording this video, the latest version of this YAML extension has a bug that prevents the Kubernetes extension from being able to generate the YAML files. So to avoid that, what you want to do is make sure that you go back to version 0.4.1 of the YAML extension. And to do that, what you can do is just click in the gear icon here, install another version, and then you will pick the version 0.4.1. And that will pretty much fix the issue. You may want to just close and reopen Visual Studio Code if needed, but then things should work as expected. And of course, eventually the YAML extension will be fixed and you will not need to do this additional step. Now let's go back to our files view. Now what we want to do is add a new file here that we're going to call deployment.yaml. And this we're going to use to describe the deployment of our container into Kubernetes. And to fill this file quickly, we're going to just type here deploy. Like I said, this is taking advantage of that Kubernetes extension for VS Code, which pops up this menu window here, which we can click, and that initially scaffolds the template for a Kubernetes deployment. So the deployment is pretty much a static description of what we want to obtain or deploy into the Kubernetes cluster. So here, first thing we're going to do is provide a name for this deployment. This is how you identify the deployment. So let's call it Hello ASP.NET Core Deployment. Next, we go into the selector labels section. And so what happens here is that you have to describe which Kubernetes pods are going to be targeted by this deployment. Okay, so the pods are really the living beings and the minimal unit of deployment into Kubernetes. And those are the ones that are going to be created or destroyed over time in the cluster, according to what you have defined it in the deployment definition. So the deployment is a static view of what you want to obtain. The pods are the living entities that actually enable your deployment in Kubernetes. So first thing, we're going to give a label for our pods. We're going to call them Hello ASP.NET Core Pod. Okay, so this is the kind of the label that we're assigned to all our pods. And what we're going to say is that our deployment should match the label Hello ASP.NET Core Pod. So that makes sure that this deployment just manages all those pods. Now coming down, we need to describe which is the container or containers that we want to include in this in the pod. We just have one container. We will name it here just as Hello ASP.NET Core Container. And this is kind of an identifier for this container. But now we have to specify the actual image that needs to get deployed there. So this will match exactly the image that we created earlier. Okay, so if you remember, if we just do in the terminal Docker images, so that image would be, and of course there's a few more images here, by the way. Let me expand this a little bit to explain this. As you can see, yes, we have the Hello ASP.NET Core image here, and we have the .NET SDK and ASP.NET image here, but we also have a bunch of other images. These are the images that were downloaded when we enabled the Kubernetes cluster in the box, and these are the images that pretty much bring Kubernetes into the box. Now, we really care about Hello ASP.NET Core right now, so that's the image we're going to use. So let me put it here. And importantly, we have to specify the tag. So in this case, as you remember, tag is v1, so I'll use that. Okay, so that's the image that needs to get deployed into this pod. Now keep going down. We have a couple of settings here, what we call the resource limits. So this makes sure to assign a few machine resources to your Kubernetes containers, so that they don't try to take over more resources than what they should use, right? To not take resources that some other containers may want to or may need to use. So the two ones that we have here is the memory and the CPU. So in the case of memory, by default, we are getting 128 megabytes, which is kind of similar to megabytes. And the other one here is a 500 milli CPU, which is kind of equivalent to 0.5 CPU, which just means half CPU, basically. So we're saying that at any given time, each container that is spin up by this pod, each container that is part of any pod of Hello ASP.NET Core pod will have 100 at much 128 megabytes and a half CPU. That's a limit that they have. And finally, we have to specify the port that the container is exposing. Okay, and that's going to become the way to get into the process that's inside the pod. And in our case, just as well, when we created the Docker image, that container port is going to be 80. Okay, now I'm going to save this file. And it's time to apply this Kubernetes file. So the command that we use for this is CubeCTL apply -f, and then we give the name of the file, deployment YAML. So hit enter and create it. So what this does, this creates a deployment in Kubernetes and spins up the creation of the pods. So if you do kubectl get deployments, you see we have our deployment here, kubectl hello ASP.NET Core deployment. And if we do kubectl get pods, we should have one hello ASP.NET Core deployment and some random GUID. This is the pod. This is saying that one of the containers in this pod are ready, which is good. Status is running, so everything is good about this container. So this container is good to go, and we can confirm that it's really alive, but by saying kubectl logs, and we will provide the name of the pod, and you can see it's bringing up the expected console output right here. Now, even when the container is running inside the Kubernetes cluster, this is not enough for us to be able to query the web API that's inside that container. We need to bring in one more Kubernetes artifact or object that we call the service. So the service is a kind of a logical grouping of objects that allows Kubernetes objects to interact with each other. And plus, in this case, we're going to create what we call a load balancer service, which allows us to assign a public IP, a public IP to or DNS name to our pods, right? So this is without this, you will not be able to reach the containers. They are pretty much alive in there, but there's no way to access them. So to do this, what we're going to do is just again add a new file. We're going to call it service, the YAML, and just as we did before, we're just going to type service here, select this, and here it is. So we have scaffolded the template for the service, and we're just going to start filling the values here. So the first thing, some name for the service, we'll call it Hello ASP.NET Core Service. So that's the name of the service. And then just as we did in the other template, we need to specify which are going to be the pods that are going to be targeted by this service, right? So if you think of a load balancer, so it says, okay, so whenever this service is reached, this service will try to get in touch with as many pods as are available of some specific label. So going back to the pods, the pod definition here, we know that the pod label is Hello ASP.NET Core Pod. So going back to service, we will use that as the selector in the service. So it doesn't matter how many pods we have, which we could have. We will just have one right now, but we could have multiples. So the service will load balance between all the pods that are using this tag here. And now this is the external port that people will use to query the service, and then target port is that port that we have specified on the deployment YAML, which is internal container port. So you will have to go navigate to port 8080, and that will be routed into port 80 on the pods that are being targeted by this service. Finally, we had to add one little piece here, which is the type, because there's a few types of services. Like you could have services that just interact with each other within the cluster without exposing anything to the outside world. But in our case, what we want to use is a load balancer, which instructs Kubernetes to allow public access to the pods that are behind this service. Okay, so now going back to the terminal, we're going to apply this service YAML there. So let's say CubeCTL apply service YAML, and the service got created. So if we say, now we just say CubeCTL get services, here it is. We have our new Hello ASP.NET Core service of type load balancer, and it does have a cluster IP. This is kind of an internal IP within the Kubernetes cluster, but more importantly for us, it's external IP, which is how we can access it from the outside. Now, of course, since the cluster is just running in our box, there's not really a public IP involved. It's just localhost. So now let's test it out. Let's see if we can actually reach this cluster. So we're now going to go to Postman. I'll create a new request. And here I'm going to query for HTTP localhost. And then we said it's going to be port 8080. And then the actual web API route, which is weather forecast, if I'm not wrong. So let's hit send. And here it is. We get results from our call to the web API, which is now hosted in Kubernetes. If this video was useful, please consider hitting the like button. Don't forget to hit subscribe and the notification bell to know right away when I publish new videos. Also, please leave me a comment below with any thoughts about this video. Thanks for watching. See you next time.